All right, so starting with example 5 here, we'll finish up the 1-2 notes and see how we're looking. So this one says identify transformations from an equation. So they're going to give us an equation, and we're going to describe what it is. We're going to graph it. This is essentially exactly what we just did in the warm-up. It's just more possibilities, more different things that are happening. So it's got the parent function graphed already. So f of x is just x squared. So this is the one that they've already got plotted on here. Here's our f of x function already drawn. Now they want us to say what transformations happen in this graph. So we're going to describe what it is, and then we're just going to sketch the graph. All right, so this one has two things happening. We have the negative that's going to reflect over the x-axis. So again, that just means we're going to have a downward facing u. And we've got this 1/3, which is a compression of 1/3. Now, there are two different ways to graph these points. I want to be very careful about this because this is one where people do make errors. So first things first, the vertex does not move. There's no shifts. There's no left or right going on here. So the vertex still at 0, 0, and we know it's going to go downward. But how do we do this 1/3? There are two ways you can do this correctly. If you're going to use the slope as 1/3, you have to do it per 1 unit, meaning for every 1/3, it goes over 1. So you can plot the point like this way. What you can't do, though, is you actually can't go down 1 and right 3. And you're going to notice the reason that that doesn't work is this graph isn't straight lines. It doesn't behave like a V-shaped graph does where the rate of change is always the same thing. This is literally saying that this rate of change is only true for the first one, and then it amps up more, and then it amps up more. So your graph's going to, describe that kind of the wrong way. This is less and less, but it's not going to follow that exact pattern in most cases. There are some scenarios where the numbers work out. So this is what I would recommend to you. Just pick a number and substitute it in. So like in this case, what number would I plug in for x? I would plug in one that works really nicely with 1/3. So for example, I would probably just plug in 3 because I know that 3 is eventually going to get divided by a third or multiplied by a third, and it's going to just kind of cancel that piece out. So what coordinate would I have if I put a 3 into here? 3 squared would be 9. 9 times 1/3 is 3, and then it just makes it negative. So that's like, basically I know then that's my point. I'm going to plot the point 3, -3. That way I know for certain I'm getting an accurate point. So all I did there was substitute a number in. You really have to use this strategy only on your x squared graphs. If it's an absolute value, then this is truly just the slope. But like I said, if you use the slope here, you actually get this problem wrong. Because if you go down 1 and right 3, that point is not on this graph. And again, the reason for that is this isn't a constant increase. This is an exponential increase where it's going up by a square every time, not a linear amount. Now, once I plot this point, I do know I have the mirror image of it over here. And so now I can use those to connect and draw my, draw my U. I don't know, it goes by 2s. Good call, sorry. So yeah, everything I said was right, but everything I graphed was wrong there. My mistake. Sorry, these should be at 3s. Good call. Should definitely look at the scale there. Thank you. So yeah, what I said was fine. The points I graphed, though, were definitely in the wrong spot. My bad there. All right. Any other issues, though, with that one? Does that make sense? Okay, so again, for x squared graphs, use picking a point to plot it method. I think that's going to be your best route to go. All right, now this one's super easy. I would rate this as one of the easiest types you'll see. Because the reason I say this one's easy is all it is a vertex shift. All you've got going on here is a right 4 and an up 5. And that's it. The graph itself stays identical. You don't mess with the shape of it at all. It's going to keep the exact same shape. The vertex is just shifted. So right 4 and up 5. Again, going by 2s here. Make sure we get in the right spot. And then the other coordinates you're going to plot are going to be exactly like whatever this one is, which you can notice is right 1 and up 1. So from your point here, you can go right 1 and up 1 to go ahead and get yourself 2 coordinates to make your graph accurate. Because again there, we don't have any sort of slope, any sort of a value that we have to mess around with. We know it's going to be just this exact same shape, just shifted. Okay? Any questions at all there? All right, then let's look at this last example. Okay, everybody's favorite, good old story problem here. So So what's going on here? This says a scenic train ride makes trips to an old mining line. The graph shows the distance y in kilometers of the train from the station x minutes after the ride begins. Okay, so when you read stuff like that, that's telling you your axes, meaning as the minutes go, you get this distance away from the train station. So just simply looking at this graph, what happens is as time goes on, they go away from the train station up to a point of where they're at 15 kilometers away. And then, of course, they come back to the train station to drop the people off from the tour. So what's the question? What equation represents the distance from the station as a function of time? So this first part is wanting us to write the equation. So this we actually have not done yet. This is giving you a graph and saying, come up with what the equation would be. Okay? And then they ask us to find the domain, which we'll worry about that in a minute. So let's talk about how do you come up with the equation. So first off, look at the shape. Based off the shape, what kind of function does this have to be?
Absolute value.
Absolute value. So we know going into it, it's V-shaped. So real quick, as you do these problems, you're probably not going to need to write down every detail. You're going to get to the point where you can just come up with the equation. But let's write down all the details we notice here. So the vertex location is also important. This vertex is right 15 and up 15. So we need those things. We need right 15. We need up 15. And then the only other thing we really got to worry about here is the reflection and is the slope different. So this is reflected because it's downward facing. So we can include that it's got to be reflected. And then lastly, we need to figure out the slope. Does this have a slope of 1 or does it have a different slope? And here's how we do that. Think about this. This is just rate of change here. This goes from 0, 0, it goes up 15 and right 15. So 15 divided by 15 means that this does have a slope of 1, which tells us that our slope in the little thing that I gave you guys the other day, I used A for the slope because it's not technically a slope. It is on a straight line, but it's not on your curved line. They call it an A value or a scale factor. So this is kind of all our information that we can pull from this. And now we can write our equation. So remember, let me just flip back to show you the thing we wrote yesterday, our transformation rule. We've got all these pieces down. We know that our graph needs to be reflected, so it's going to be negative. We found out our A value is 1 in this case. Our function is absolute value, and then it's going to be shifted right 15 and up 15. So we just have to write it with all that information in there. So let's go ahead and write it out. So they don't give us a function. This is just a y and x equation. So we can go ahead and say, and I'll put it here, be good. Y equals. And so going down the line, reflected, that gives us the negative. So I'm just going to kind of check them off as I go. The A value is 1. So if you really want to put a 1 here, you can, but you don't need to, so I wouldn't. So that's all taken care of. V-shaped, absolute value is going to give us that. So we're going to need an absolute value signs. And then lastly, there are shifts. So here we're going to go x minus 15 to shift it to the right and the absolute value. And then you throw a plus 15 on there as well. So now we should be totally good. We've got our reflection, slope of 1, absolute value is V-shaped, right 15, up 15. So again, as you do these, you may not need to make this checklist every single time. But again, I'm just kind of laying it out for you so that when you see your notes, you know what we did here. We identified all the stuff from the graph, and then we wrote the equation. The only other part of this problem, make sure we finish it. It says, what is the domain? Again, domain is what x values does it span? X values go from 0 to 30 because that's the length of the tour in this case. So 0 to 30 minutes is the length that they're going for. So I'd say my domain would be from 0 to 30. It doesn't ask for it, but if it did, we could give the range. Okay, the range, the distance, the lowest is 0. The furthest away you go is 15. So we could write a range 0 to 15. Okay, and that's it.